My name is Alan Krause. I'm the President and Chief Operating Officer for MWH, and I'm here today to tell you about an exciting project that we're working on in the Panama Canal, a project that we believe is one of the largest and most significant civil engineering projects of the century. The original Panama Canal was built from 1904 to 1914, and as most of you know, it's a key trade route connecting the Atlantic and the Pacific Oceans. Today, more than 815,000 vessels have passed through the canal, averaging about 14,000 annually. The canal was named by the American Society of Civil Engineers as one of the 7 modern wonders of the world. The Panama Canal today handles about 5% of all global trade. And a ship sailing from New York to San Francisco via the canal travels just under 10,000 kilometers, which is well under half the 22,500 kilometers that the ship would follow if it went around the southern tip of South America. Today, 80% of Panama's economy is linked to the canal. In 2009, the Panama Canal Authority announced an expansion project for the canal to allow larger ships to pass through. The expansion project will add a 3rd set of locks and will be completed by 2014, which is precisely 100 years since the first canal was built. We are part of a joint venture that includes 4 large consulting companies. The acronym is GUPC. It includes Cecere from Spain, Imprigio from Italy, Jan de Newell from Belgium, and CUSA, a local Panamanian construction company. GUPC is leading the construction on the 3rd set of locks, and we are contracted directly to them. The locks are required on the Panama Canal to account for the change in elevation between freshwater that exists in Lake Gatun and both the Atlantic and Pacific Oceans. The 3rd set of locks will expand the canal's capacity through integrated components, including 2 lock facilities, one on the Atlantic side and the other on the Pacific side, each with 3 chambers that include innovative water-saving basins. The new locks will allow for much larger ships, called post-Panamax ships, to pass through the canal. These ships measure roughly 1,200 feet long and about 160 feet wide and can carry twice as many cargo and cargo containers as ships that currently pass through the canal. Cargo capacity in these ships will increase from about 5,000 containers to about 12,000. Serving the design needs of the project, the CICP design joint venture, which is led by MWH, also includes IV Infra and Tetra Tech. We are currently near the peak of the design process for the project, with more than 240 professionals working on the project from the CICP joint venture. The integrated global design team includes staff located in our offices in Milan, Italy, Bellevue, Washington, Buenos Aires, Argentina, Rotterdam in the Netherlands, our Chicago operations in Illinois, and of course, we have a full staff in Panama City, Panama. The team uses high-tech computer and physical models to conduct a series of required tests to confirm the expected performance and capacity of the locks. In addition, the team uses very sophisticated project management software and design tools to work on this globally integrated project team. The CICP design team is delivering cutting-edge, sustainable solutions that will enable rapid opening and closing of the gates and efficient filling and emptying of the locks based on innovative hydraulic designs. And the water-saving basins, the largest in the world, will reuse about 60% of the fresh water consumed for lock operations. State-of-the-art analysis techniques will ensure that lock wall configurations meet very stringent seismic criteria. The lock wall designs incorporate drains that reduce the static and the dynamic loads on the walls, reducing their section and size, while achieving the required performance goals related to deflection and durability. The lock gates are sliding versus the miter gates that exist in the current canal and are arranged in pairs for safety. The length of the locks account for the length of the ships plus the tugboat that will be used to tow the ships through the locks. The filling and emptying system includes the major hydraulic components that move water and ships through the Atlantic and the Pacific locks. And this includes the water-saving basins. The design for the filling and emptying system was approved in February of this year, 2011, following a series of tests on the physical model. As a result of model testing, this has led to better hydraulic performance, both faster and less turbulent, and a projection of easier vessel handling during filling and emptying of the locks. The physical model confirms the hydraulic performance of the locks and provides the Panama Canal Authority with the highest degree of confidence in ship transit safety and capacity. The design system allows significant time savings for the complete filling of the chambers, which has had a major impact on the number of transits made possible by the three-stage locks. The design specifications call for savings in reusing approximately 60% of the fresh water used in the lock system. This is an important advancement in a country eager to conserve its freshwater resources. And the designers in the CICP joint venture, led by MWH, optimize these water-saving basins to improve the filling and emptying times. The basins have a large footprint. Each of the 3 basins per lock chamber is the same length as the lock chamber, but is only 8 feet deep. This design is the first for a project of this size anywhere in the world. The water-saving basins are one of the most important and challenging aspects of the design. Here's why. The Panama Canal relies on nearby Lake Gatun, a man-made freshwater lake that serves as a reservoir to operate the canal locks. The lake is also a source of water for Panama City. During wet months, when the lake is full, excess fresh water is essentially lost to the ocean when the locks are in use. In fact, upward of 52 million gallons for each passing ship can be used. At the same time, rainfall is seasonal in Panama, so there are lower water levels and supplies during the dry months. The water-saving basins in the 3rd set of locks minimizes the impact of these factors by maintaining proper levels of fresh water for the locks and the people of Panama City. MWH engineers needed to determine the best way to implement these water-saving basins to address the varying water levels and water needs for Lake Gatun. Seismic design for this project is the most sophisticated analysis we've ever undertaken. We used a state-of-the-art seismic impact analysis to help us design the lock walls, make sure those lock walls are smaller in size while doubling the amount of stresses and strains the structure could withstand during an earthquake. The graphic demonstrates there is considerable greater seismic concern on the Pacific side over the Atlantic side. An integral component of the systems is also a device that enables the operations of the locks to maximize safety conditions for navigation of the whole lock system. The lock gates have the potential to operate faster than specified with our optimized gate design, motor, and control systems. Combined with an efficient filling and emptying system based on innovative hydraulic design, the benefits could potentially allow more lockages per day, which could lead to a better service and increased revenue stream for the Panama Canal Authority. Active construction has been taking place since mid-2009 in preparation for the new locks. You can see this view of the Pacific side taken several months ago, and this is a rendering of the aerial view of the Atlantic side of the 3rd set of locks. And from the rendering, this view of the Atlantic side of the canal is under construction. From the photos, it's easy to see that there are some pretty large differences between the soil conditions from one side of the canal to the other. And by the way, on the Atlantic side, we're dealing with sediments, and on the Pacific side, we're dealing with igneous rock. The Panama Canal project is an exciting project for us as engineers. The canal expansion is one of the world's largest profile designs and construction projects, and it will impact global commerce and will help change and improve the way goods are transported around the world. It will provide sustainable water and energy needs, and our design work will help influence future engineering and water-related projects. The Panama Canal is one of mankind's greatest accomplishments. It has shrunk the world and opened up endless opportunities for global commerce. Today, nearly a century later, MWH is proud to lead an international design team designing new locks that will double the canal's capacity and keep the world connected for another 100 years. Thank you very much.